Okay, so the last thing we're going to go through is hydrolysis. And we're going to use our example here to show you what would happen there. Okay, so I'm going to get rid of the monomers. Just keep in mind what they look like though. Okay? If we're asked to identify the products from hydrolysis or hydrolyzing a polyamide, then you need to know the conditions that have caused it to hydrolyze, whether it was with an acid or with a base. The easiest thing for you to do is to look at the products and see what nature they have. But for this one, hydrolyzing suggests that it'll be with water. Okay, so we ignore this one. This time, we're going to look at breaking it up with water. And my suggestion to you is if it's acid hydrolysis, it's not H2O, but what happens to an acid when you put it in water? What does it make? Which ion? Hydronium. So if it was acid hydrolysis, you're adding this. And if it was base hydrolysis, alkaline, what happens when you put a base in water? OH minus, okay? So actually, we're only looking at those ions being used to break it apart, okay? So, same idea as before, they're going to break them at the amide link. Okay, it's the only place that these chemicals have got enough effect on these polymers. They'll only break them here, nowhere else. So that's what we're going to do again, is we're going to write what happens when we break them there, and then have a look at what happens. I'm going to use red for acid hydrolysis, I'll use blue for base hydrolysis, so you can see how the two products are slightly different. Okay, so if I break this up here, we're going to end up with the same thing to start with, whether it was acid or base. And same over here. Okay. Going to work with H3O plus first. How much of the H3O plus could I add in here and make a chemical I've met before? How much of it? Okay, so hydronium is that. How much of that could I cram into here? Not sure? Okay. That lone pair will go quite nicely in here to start with to create a bond. But then what will happen is two of the H's will be released as that happens. Okay? So what you'll end up with is something we've met before. A carboxylic acid. The other mole or molecule of hydronium that gets around that will do the same thing over here. Okay, sorry, it's not particularly tidy. So I'm going to end up with my dicarboxylic acid. Which is what we talked about earlier when we were going through this stuff. Okay, what's left over from H3O plus? I've used an OH. What's left over? How many hydrogens? 2 for each side. So actually, you need to cram in 2 more hydrogens. Is that allowed to happen? What would happen to... So that can happen because the nitrogen's got lone pairs of electrons. They can attach there. But what will that mean about this product? Very good. It's an ion. Okay, the whole thing has got a +2 charge because it's an ion. All right, it's a diamino salt. Right, it'll make a salt. Okay, so let's say it's HCl. This would be in a relationship with chloride ions. Okay, making a diamino salt, which we should have meant when we did amines. Amino salts we did. Okay, so that's quite easy. We've seen where that goes. Okay, now I'm going to go back the other way with the alkaline conditions, you need to put something on that nitrogen. So what out of those two have we met before can go on the nitrogen? H. Okay, but that only leaves what? What's left over for us to put on the other one? Oxygen. Okay. That's a small problem.
Do you have to have another H here?
But we haven't got it because it's under alkaline conditions. So what? We've got a problem. But is this, let's ignore that half, or ignore this half, is that something you've met before? COO something. Sorry?
It's a
Carboxylate. Iron. Good. So just like that one forms an iron, this one forms an iron. What charge?
Negative.
Good. Negative. And so there'll be a negative on that one and a negative on that one. So, under acidic conditions, you make the carboxylic acid and an amino salt. Under alkaline conditions, you make the amine and a carboxylate salt. This understanding is what gets you merit and excellence. Okay? Identifying the monomers will get you achieved. But actually, showing how it's hydrolyzed, broken up under realistic conditions, acid or base, is what's going to get you the higher grade.
Will we have to do both in the exam or just...
Yeah, often the questions that you'll see in NCA will often ask you to compare and contrast the hydrolysis under alkaline versus acidic conditions.
So
Okay.
if we were to just describe one, is that likely to get us in merit? Or
If you got the charges right, you'd probably get merit because you've explained an understanding of one of those. To compare and contrast, that means how are they similar? So they're both hydrolyzed, breaking at the amide bond. Comparing and contrasting would be needed for you to get excellence. Okay. Any other questions before I stop this? Cool. I have broken up into two videos just so you're aware because I saw how long it was getting.